So hi, I'm Christophe Pettus, and thank you very, very much for joining. We're going to be talking about the Postgres role system here. Just the quickest of intros, I'm the CEO and lead consultant at PGX, so this is a PGX Big Happy Family pug meeting. I've been a Postgres person for a long time. My first version of Postgres was 6.5. My personal website is thebuild.com. These slides will be posted there at some point in the next few days after the meeting. And there's my email address. Okay. Now, very important note, this is about the Postgres role system as it exists in version 16, the most recent version. This is important because there were some significant changes between 15 and 16. We'll talk about what those were, but just so you know, some of this information only applies to Postgres version 16, and if you're not running it, you should be. Okay, so let's start with the why is there error question. What is a role anyway? Everyone sort of like has encountered them, but what are roles? It's that thing you use to log in. You say it's Postgres or your name or something or RDS admin, and that's part of it. But roles are a lot more. The Postgres role system is very sophisticated, and you can do a lot with it, and you can get it a lot wrong. So let's see what you do. So a role has basically three roles, inside of Postgres. The first is it's an object, it's a thing in the database that holds privileges and has attributes. Privileges and attributes are different things on a role, and the distinction is important, so we'll talk about the difference here. Roles are also used to authenticate access to the database. If a role has the login attribute, it can log into the database. Every session has a role associated with it at any one time. It doesn't have to necessarily be the role that was used to log in. You can adopt a different role as in a session, but at any one time, a role always has a current user. It's called current user in Postgres. We'll talk about users versus roles in a moment. We're not going to talk about authentication. That's a big topic of this talk. Would go on for forever if we added that. Also, it's used to control ownership of objects in the database. Every object in the database is owned by a particular role, and often that is that is the role that was active in the session when the object was created. Sometimes, but it can be a different role. Okay, so we'll see the word user used a lot. There is a create user command in Postgres. We talk about users logging into the database, but the only thing a user is a role with a login attribute. That's it. There are no tricks. There's nothing else that's about a user that makes it a user. It's just that login attribute. So we're going to use the term role for everything exclusively here. So anytime if the word user slips in, just think role. Unfortunately, Postgres is not 100% consistent about this, so there are some places where it uses user that it really means role. And you'll also occasionally see things called a group, like there are obsolete command forms that have the word group in them. A group is just a role. There's no special separate thing. That's a group. Okay, first big thing about roles is they're cluster-wide. Now, I'm using the term cluster in the traditional Postgres sense, which is one instance of a Postgres server that can contain multiple databases. It's somewhat unfortunate terminology because the term cluster is also used for things like a primary plus all its replicas and things like that. But we're going to use the term cluster in the traditional one instance of Postgres sense here. And they're global objects. They're not specific to a particular database. So they're one of the few things that are. Using privileges, you can restrict access to particular databases to different roles. You can prevent a role from logging into a particular database, but the role still, in some sense, still exists in that database. However, the privileges that you give to roles are all database specific. Just because you can select from table T in one database doesn't give you the rights to select from anything else in a different database. And if you're doing a PG dump, remember the roles don't come out of a PG dump if you're dumping a single database. You have to use dump all to capture them. A very traditional pattern is to use a globals only dump all to dump all the roles, and then a PG dump to dump the database. Okay, so now that we understand roles, let's talk about privileges. A privilege is another object in the database. It's a persistent thing that lives inside the database, and it's a permission for a particular role to perform an object on a database. Specifically, the role that a session is. So if a session has a particular role, if it has the privilege to do something on an object, then it can do it. And these are things like select from a table, create a new table of schema, call a function. The term is a role has a privilege if the privilege object exists in the database that grants that role that privilege. So, and you can only perform the operation if the current role has privilege to do it. But there are all kinds of different ways for a role to gain privileges. So, how can you get a privilege in Postgres? And there are, I believe, 6 different ways that I talk about here. The first one is be a super user. This isn't actually cut and pasted from the Postgres code, but it shows you what it's like. Super users can do anything. It's not really that a super user has all the privileges. It just doesn't matter what privilege it does or does not have. If it has the super user attribute, the answer is yes, always. It doesn't even check anything else. When you create a new Postgres cluster with a initDB, you get one super user role automatically. It's called Postgres. You should really never have any more. It's not a great idea to create a bunch of super user roles. Usually you want to create just one and have it sort of be the lead that grants privileges to everybody else. And being a super user is an attribute of that role, not a privilege granted to the role. And again, this is this attribute privilege distinction we'll talk about in just a bit. The other way you can get a privilege is be the object owner. The role that creates something is its owner, unless some commands have a syntax that lets you create an object and at the same time give it to a different role. The owner can give away ownership. An owner can take up an object and say, okay, it's yours now. Here, have it. Wee, splat. But it can't do it to just anyone. And if you think about it, this kind of makes sense because you could maliciously transfer a function, say, to another user, and then it shadows another function and they call it and they're getting the wrong function. It's just bad. So you can only give ownership to a role that you can set role to, that if you can change that role, you can give ownership to it. Initially, the owner has all available privileges on that object. Each object has a set of privileges that can be granted to it. And when it's created, the owner has everything. And usually no one else does, although with some exceptions we'll talk about. However, the owner can revoke all these privileges even on itself. So it can deny a privilege to itself with the exception of the privilege to alter or drop an object. The owner always has that privilege and it can't be revoked from the owner. The third way is you can do something that's granted to public. Now, public is a pseudo role. It doesn't really have all the characteristics of a role, like you can't log in with it or do stuff like that, or it can't own things. But in effect, all roles are members of this public role, and they inherit all its privileges. So anything public can do, all roles can do. You can't grant every single privilege that's available in the system to public. There are some limitations. However, on a brand new database, some are granted by default. Public starts up with a few privileges, and that can be a surprise because suddenly a role you create can do something that you didn't expect it to be able to do. And also, in unfortunate terminology, there are two publics in Postgres. There's the public role, which is what we just talked about. There's also a public schema, which is the first schema that's created inside every database. That's sort of the general playground and where things go if you don't tell them to go someplace else. So these are different things, and they don't really have any relationship with each other. I've tried to write the role in caps and the public schema in lowercase consistently here. Number 4, and this is the one that, of course, is the most interesting for this talk. You can get a role by having it granted to you. For example, this says, okay, on table T, grant select to my role. So my role can now issue a select command for that table. You can also revoke it. So there's the matching revoke command. Now, where it gets interesting is you can also have a privilege because you inherited it from another role. Roles can be members of other roles. That's why the word group existed, because you could have a role that has a bunch of child roles under it. And any in the default case, if a role, you have a parent role and a child role, the child role automatically can do anything the parent role could do. With some except, however, there are ways of changing that behavior, and we'll talk about those, of course. And this is where the privilege versus attribute distinction comes in, because only privileges are inherited, not attributes. So, for example, if you add a role as a child of a super user, it's not automatically a super user. It doesn't inherit that attribute. So we'll talk about role inheritance. So again, a role can be a member of another role, and it's a directed graph. One role can be a member of any number of roles, and a single role can have any number of child roles. If you don't do anything else, you just sort of you say, okay, this role, put it in this role. And the way you do that is with the grant command by granting the parent role to the child role. So grant parent to child. And this is recursive because the privileges build up as you work your way down the graph. So the ultimate children have all of their parents' privileges. So, the union of all of them. And you can assign a role as a member of a group when you create it, when the parent is created, or later. So lots of different options there. So here is a extremely sophisticated graphic that shows two roles and a role that is a child of both roles, and it has all the privileges, the little colored box of privileges. I hope this makes everything much clearer. Okay, so you become a member of a role with a grant command. Or when you create the child role, you can say create the child role and make it a member of all these roles. Or when you create the parent role, you can say create a parent role and put all these child roles into it. They all have the same, at the end, it's all the same. There's no difference in operations after for these commands. It's just different ways of doing the same thing. So the grant itself has some options associated with it. The documentation consistently calls these options, so we're going to use that term. So if you grant with set, that means the child role can set to the parent, use set role to adopt the parent role. Without that, it can't. So this is an important role if you're creating a role that you want the children of it to adopt. And you have to be a child of a parent to adopt the parent, which makes absolutely no sense in that terminology, but you get the idea. This is something that's brand new with version 16, which is you can grant membership with admin. You can think of this as that the parent is a grouping of roles of some kind, and you add a role, but you say, okay, and you're an administrator for this group, which means you can add and remove your siblings from this group. There's kind of a parallel thing with grants of a privilege called with grant option. We'll talk about that. So set by default, set is true and admin is false, which makes sense. But this means you can have a role that is somewhat more powerful than the other roles that belong to that same parent role, because it can add and remove members. Lastly, there's the inherit option. If inherit is set, then we get the inheritance we just talked about. But notice you can turn it off. So a child role can join the parent role, but not inherit any of its privileges. So you can create with no inherit, which it won't inherit anything from any parent. No inherit is a characteristic of the child, not the parent. There's no way for a parent to say nothing can inherit from me in Postgres. You can only mark a child as saying, I don't want anything from my parents, very independent. And inheritance is all or nothing. You get all the privileges of your parent or none of them. And you can't revoke an inherited privilege on the inheriting nodes. So for example, you have a parent that can select from table T. A child joins it. Now it can select from table T. Even better, let's say the parent can select and update table T. The child joins it. Now it can select an update. But you can't revoke just update from the child, for example. The only way to get rid of those privileges on the child is to just turn off the inheritance by using no inherit. And if a child doesn't inherit the privileges of a parent, its children can't pass them on to its recursively pass them on to its children. The privileges stop there. So a question is, well, so why would you want to be a member of a role you don't inherit from? That seems like not a very useful operation. And that's because there's a sixth way of getting privileges, which is you can switch to a role. A session can change roles, and you can change to a new role if you're a member of that role. That role is one of your parents, and the that inheritance that membership has the set option. You have to have both of these, and the set option descends down the inheritance chain. So you can adopt a parent that's way up in the hierarchy as long as there's an unbroken chain of sets up to that parent. There's also another thing that set lets you do, which is if you own an object and you want to give it away to another object, you have to have the set option on that object, on that new role. So because you have to be able to adopt that role. Okay, well, we've talked about how you get privileges, but we haven't really talked about, sort of like the root of them. Where do they come from? So ultimately, a role is granted privileges by another role using the grant statement. So a super user can grant any privilege to any role. That's sort of how you get started with Postgres, because you have a Postgres user that can create new roles and grant anything to anything. And a role can grant another role a privilege if, when it received the privilege, it received it with grant option. So if role X gets a grant to table T with role X grants table A select on table T. We'll assume role X is able to do this with grant option. Now role A can hand out grant option to other roles, just like, and there's the example. So grant has there's different ways of doing grants. The lighter text are noise words. You don't actually have to put them in. So for example, the word table is optional in grant. So you can grant select to role 1. You can grant everything on table to role 2. By the way, I use select as an example here, but you can grant any set of privileges. It doesn't have to be just select or even just one. You can grant everything on T to role 1. You can grant all privileges in a particular schema to a role. So so you can say, okay, everything that's in this schema, grant everything to role 2, to role 1. You could also have individual privileges there as well. You can grant select with grant option. And there is a little extra thing you can tack on that says who granted this role. This is in Postgres, doesn't really mean anything because the only thing you can put in granted by is your own role. So you can't say, and by the way, make it seem like this other role gave you the privilege, because Postgres does track which role granted did the grant of privileges. So an owner can grant any privilege on an object, even if the owner itself doesn't have that privilege. That privilege was revoked from the owner. This does mean that an owner can restore a privilege to itself that's been revoked. So you can revoke select. Let's say you're a super user and you revoke select on a table from its own owner. The owner can just come back and grant itself select again. So this feature does not provide any security. It just provides safety, so that in case you didn't want the owner to be able to do this operation for some safety reason. And again, the ability to modify using alter or drop an object, it acts like a privilege, but it can't be granted. So there's no way for an owner to say, okay, you now are able to drop this object, except for transferring ownership entirely. It can be inherited though, so it does pass down the inheritance tree just like any privilege. Okay, and if you have a privilege, you can have it taken away. A super user can revoke any privilege, again, obviously. A role can revoke any privilege it granted. So if a role is marked as being the one that granted a privilege, that role can revoke it. Now, it gets a little complicated if you grant a privilege and then with grant option, and then that role gives it to a bunch of other people. and then you revoke it from the role that you gave it to, what happens? And the answer is, if you don't specify cascade on the revoke, you get an error saying, sorry, it's been given away. It's been given to other roles. If you add cascade, it will remove it from the role that you gave it to and all the roles that other role gave it to. And you can also just revoke the with grant option. So let's say A grants something to B, grants a privilege to B with grant option, and then B grants it to C, D, E, and F. A then says, I'm taking away your grant option, B. B will keep the privilege, but C, D, and F saying we'll have it revoked from them. So, if that's the behavior you're looking for. You can also revoke the inherit set and admin options on a membership relationship. Grant has some variations here. You can grant select on all tables in all schema to a role. As a one-time operation, you've now granted a bunch of tables a privilege. This is a one-time operation. It doesn't remember that and then add the privilege in the future. There's another way of doing that. And you can also say all privileges so that you can grant all privileges and then just revoke a couple if you want. So you have granular control over it. So you can grant extra stuff to public if you want. If you grant a privilege to public, everything that rolls in the system automatically has it with no further operation required. And if you revoke them from public, it revokes them from all roles if the role gets them from public. If the role gets them from somewhere else, then it'll still keep that. Privilege. And you can't grant a role to public with grant option because, well, first of all, you could really cause some interesting situations that way, but also every role is getting it anyway. So what would grant option mean in that case? Okay, this has its own slide because it can be very confusing. Grant is an object. A grant creates an object in the database. That's a grant of a privilege. Revoke is an operation. There is no revoke object. All revoke does is delete that grant object. You can only revoke what was granted. So the only thing you can do with revoke is revoke a privilege that was granted somehow. It doesn't block the privilege of the object if you get it from somewhere else. As a simple example, let's say you have two parents and a child. Both of them give select on table T. If you and then you revoke it from the one parent, the child will still have that privilege because it's getting it through a different path. So the way of thinking is that grant creates a privilege object, revokes deletes that object, but there is no revoke object. If you revoke a non-existent privilege, you may or may not get a warning. Sometimes it'll give you a warning, but depending on the precise situation. But sometimes it'll just say, "Okay, done," and then you discover something. You have a surprising state afterwards. Here's an example. Okay, we're in database Z. The current user is X. Okay, so now we create a function. That function is owned by the current user, which is X. So we select from it. Oh, look, it works. And then we revoke it. It still works. Now, what you should be thinking is, well, yeah, that's great, but this is a dumb example because X is the owner. So of course X can still select from it. Even because the owner has all privileges or something like that, right? Okay. But let's do something different. Let's revoke execute on the function from a different user. Why? We sign out, we sign back in. I did a sign out and sign out rather than a set role, but you can do that too. Now we can still select from it. Wait, is the whole Postgres role system broken and it doesn't actually work? Well, no, that's not what's going on here. That's because Y got its execute privilege via public. Because public, by default, when you create a new database, has certain privileges on some database objects. It has execute on all functions and procedures. It has connect and temporary on databases. It has usage on language and types. The database owner or super user can revoke these, but be careful. Do not say, oh, I'm going to be super secure and just revoke everything from from public, because you could end up with a very kind of unpleasant state in the database. So understand what you're doing. But the one that is specifically surprising is that by default, every user is granted execute on all functions and procedures. That one can be surprising. Okay, so we've been back before I was talking about attributes versus privileges. So let's talk a little bit about attributes. Roles also have attributes. This is what the documentation calls them. In addition to the privileges granted, they aren't granted. They're assigned when the role is created, or you can put them in with alter role. They're never inherited. So they're unique characteristics of that particular role, but they don't pass those abilities down to other roles. So here they are. Whether or not they're super user, whether you can create a database, whether you can create a role, whether you inherit stuff from your parents, whether you can log into the database, whether you can do replication things. Pragmatically, if you have replication, you have to have login to. Whether you can bypass row level security, how many connections that particular role is allowed in the database, the password, a valid until after which the password becomes invalid, what roles it's a member of, in group, which is the same thing. You know, this is one of the places you see the word group, but it means exactly the same thing as in role. What roles are a member of it, what roles it can administer, and setting a configuration parameter. And that the setting a configuration parameter is a very powerful characteristic of Postgres we'll talk about in a moment. In fact, now. So you can set a configuration parameter on a particular role, which means that when that role connects to the database, it's just as if you issued that bunch of set commands in the command line. It doesn't set it when you do a set role to that role, however, and it's not inherited, which is kind of a shame because those would be useful features, but it doesn't. That's the way it is. And it only works with configuration parameters that you can set using the set command. So you can't change shared buffers this way because that requires a restart. Okay, version 16 introduced a really powerful new feature, which is that you can practically administer a role without using a super user. So if a role has the create role attribute, it can create new roles in the database. The name kind of gives that away. It's automatically granted the admin privilege, and it can grant admin to existing roles as well. So you can create a role that using create role, you can create new roles and give them and administer them with that role. But that create role user does not have to be a super user. So that's very powerful. So for example, if you can a role with create role on itself, and that has the admin on its parent role, can add and remove parents to the parent role, like you can add and remove siblings basically. Obviously, create role by itself, you can't create a super user role or replication roles. Replication roles really should be treated with kind of the same gingerliness as super users because they have a very high level of access to the database. Before version 16, there was no admin privilege. That was the big revolution in version 16. So a role with create role can change other roles in the system even if it didn't create them. And a hostile role with create role can break out of many access controls and start doing super user-like things, and which means it can do things like access the underlying file system. So it really required a high level of trust, which was kind of defeating the role of the purpose of having these roles. We said at any one time a session has a role associated with it, which is true, but it actually has three. I say two here, but it's really three. The current role, which is the role that is used to check all the privileges. It's the one that whose privilege set is important. You can get it with the function current user. Current user is a really weird because of taken up with the SQL standard. Current user is a function that you can't put parentheses after. So there's no paren after it. Why? Who knows? There's also the session role, which is usually but not always the role the session logged in as. If you do a set role to a different role, current user will be the new role, session user will be the old role. Similarly, if you have a function that is defined as security definer, That is to say, when you run it, it adopts the role that created it. Current user will be the role that created that function. Session user will be the role that invoked, the outer role that invoked it. There is one way to change your session user as well. And if you want to make sure you know exactly which user was used to log in, you can get the system user, which never changes in the life of the session. The system user actually returns a text blob that includes the authentication method, but you can parse the user out of it. There are actually two ways of adopting a new role, and they're kind of confusingly similar. There's the one you want to use, which is set role. It changes the current role to the role. The old role must be a member of the set role with the set option, or a super user. Super user can change role to any role. You can reset back to the session role or to the original authentication role, and 100% minus epsilon cases, these are the same. Non-super users can use this to temporarily escalate their privileges. I'll show you an example of that, kind of like using su or sudo on the command line. Use this one. The one I'm about to show you, I'm only showing you for completeness reasons, don't use it, which is set session authorization. It can only be used by a super user, and it changed both the session and the current user to the new role. Why? Who knows? I have yet to find a use for this statement. Maybe there is one, but I have yet to find a use, so just don't use it. Use set role. Okay, so we've talked about all the mechanics of privileges, but what privileges are there? So each kind of database object, or class of database object, has a set of privileges that it can be assigned to it. Some privileges share a name between classes of objects, but aren't really the same, like usage. A schema has usage, a foreign data wrapper has usage, but they aren't really the same thing. And not every combination of privileges makes sense. Specifically, there are some privileges that really are only useful in conjunction with another privilege. So tables, which is, of course, the most interesting one, there has this set of privileges. Some to note is that you can give a role just insert on a table and nothing else, so it can't get any data out of it. It can just put data into it. However, if you're doing an on-conflict update, it needs update too. That kind of makes sense. Update and delete. In theory, you can grant update and delete by themselves and no other privilege, but you can't use a from clause or a where clause in the updated delete. There, you can only do a table-wide update or a table delete. Not that useful. So de facto, you need to give a select as well, so it could use a predicate, a where clause. And there are two that are specifically about creating things associated with it. References allows you to create a foreign key constraint pointing to the table. So you can add a foreign key constraint to a different table pointing to that table. And trigger lets you create a trigger on the table. These guys, insert updated, can be granted on individual columns instead of the entire table. So you can say this role can only update this column, which is kind of useful. If for update, for insert, you have to insert a row or not. You insert a row or you don't. So if you don't grant it on particular columns, they either have to have defaults or an appropriate before trigger that sets them before it actually goes into the database. If you have access to the whole table, you can't then say, okay, grant everything all on this table to some, and say now I want to revoke it from column X. You have to revoke the whole the table wide grant and then add in the columns again. There is also, Postgres has a feature called row level security that allows you to access limit access by characteristics of the rows. This is beyond the scope of this talk, though, and it's only tangentially related to the privilege system. And you can grant on an individual table or all the schemas at once. But if you grant them to all the tables in a schema, new tables added to that schema don't automatically adopt those privileges. Use exactly the same command on views and materialize views. In fact, you can use the keyword table there to make it very confusing. So you can say grant something on table V where V is actually a view. There's no grant on view for some reason. Oops. Just a little note about indexes. Indexes don't have their own permissions. When a role has a privilege to do something on a table, it has sufficient privileges to use indexes to do that thing. So, for example, insert implies a privilege to scan the index to implement a check constraint. And there's no way of preventing a specific role from using an index, from using a particular index. They don't have their own permissions. Sequences, however, do have their own permissions. And this often can cause surprises when you grant privileges on a table, but forget to grant the privileges on the sequence. You then try and insert something in the table, but you don't have privileges on the sequence, and you get an error. So if you're granting insert on a table, you probably need to grant usage on the sequences associated with it. And Postgres won't warn you that you have to do that. You just have to know. Schemas only get two privileges, which is create. If you have create on a schema, you can create objects within it. And usage, which means you can use things that are in the schema. If you don't have usage, that schema is now opaque to you. You can't get at things inside of it, even with a fully qualified name. Databases have privileges too. There's create, which allows you to create new schemas, but not automatically stuff inside those schemas. And as it happens, it uses that same privilege for creating a publication and trusted extensions. If you have create, you can do all three of those. They don't have individual privileges for themselves. If you have connect on the database, you can connect to the database. Kind of makes sense. Remember that connect is one of the things that is granted to public by default. So you have to have both connect and login. You have to have both the connect privilege and the login attribute to log into the database. You probably just want to use the login attribute to control access here and leave connect granted to public. There's also a privilege that specifically is the one that allows you to create temporary tables. It's automatically granted to public and only revoke it if you know what you're doing. Generally you want all roles to be able to create temporary tables, but if you want to restrict it for some reason, you're allowed to. However, to do that restriction, you have to revoke it from public and then re-grant it to the roles that you do want to be able to create temporary tables. Functions and procedures only have one role, own privilege, which is execute. It lets the role execute the function. Okay, great. I'm using the term function loosely here because if you use all functions and procedures have a different set of are different in this case. So if you grant a role privileges on all functions, you haven't granted it all procedures. A procedure is a top-level construct, relatively recent in Postgres, that can do transaction control, things like that is used with the create procedure keyword. They're generally thought of as kind of the same animal, but in this case, they're different. So if you grant execute on all functions, you have to remember to explicitly grant them on all procedures, or you can just say all routines, which does both. These are things that just have usage. If you have usage, you're able to use them. If you don't, you aren't. If you want to cause a bunch of mayhem, you can revoke usage on int or something. That would be kind of exciting. And there are a few objects that are kind of exotic, like table spaces. The only privilege it has is create. So create allows a role to create a new table space. There's no privilege that prevents a role from using a table space, however. If it's created and any role can use it, assuming you could use the tables inside of it, of course. Database parameters actually have set associated with them. You can grant set on a particular database parameter to allow non-super users to use set super user only parameters. There's also an alter system that allows you to alter the system to issue an alter system on that parameter to set it globally. Generally, these are used these all kind of work together for systems like RDS, like Google Cloud SQL, that are very locked down and you don't get a real super user. This kind of lets you create faux super users that can do a lot of the super user actions without actually being a super user. Large objects have select and update, but don't use large objects. Large objects or lobs are a built-in feature of Postgres that's now considered semi-deprecated. They still work okay. This is not the same as like byte and things like that. This is a specific large object feature. Remember that doing a grant on all tables, for example, to a schema doesn't change anything that's newly created. There is, however, a way of doing it, which is the alter default privileges command. It sets the default privileges for newly created objects system-wide or in a particular schema, and for a particular role and all roles. So you can say, anytime you create a table, this role always gets select on it, or all roles get select on it, or something like that. If you could drop a role. The only catch here is if the role, first of all, you have to have the right permissions to do so, and privileges. And if the role owns objects, the system won't let you drop it. It'll just give you an error. There is, however, a resigned owned command that lets you take everything that's owned by one role and move it to another role, which is you can do that, then drop the role. And if you drop a role that has members in it, it doesn't drop those members. It just removes the child-parent relationship. Postgres defines a bunch of handy predefined roles. These are roles that have a bunch of different permissions associated with them for doing useful things. Some of them have things that you can't really recreate with the role system. PG monitor allows reading the system statistics views and a bunch of other system statistics. Usually, if you have a monitoring agent, you can grant this so it can get everything it needs to monitor Postgres without being able to change things. There's also a read all data role, which if granted to a role means you can select from anything, even if you haven't been explicitly granted permission to it. The only catch there is it doesn't bypass role level security. Unless you give that role bypass row level security. So the row level security feature will still be applied to it. This is handy for a role that does PG dump, so it can read everything without having to write it, without having to grant super user permission or something like that. And the last one is signal backend. Normally you need to have super user permissions to signal a backend or be that same user. This allows you to create things like DBA roles that can signal a backend to use PG cancel, PG terminate backend. So, okay, having gone through all that, let's take some examples. Now, these are only. I call this a cookbook. That's probably not a great idea on my part. Don't just cut and paste them all out of the slides. They're intended as inspiration rather than verbatim scripts to run. So, for example, let's say you want to create an OLTP user. That's like the user that your website uses to connect into the database, and you want it to be fairly limited in what it can do. So you create the user, you grant usage on the schema, and grant usage on schema. You might, for example, revoke the ability to create temporary tables from it because it doesn't really need that. Up to you whether that's important or not. So it can see all the tables in the public schema, and you repeat this as necessary for the grant usage and grant all for all the schemas that exist already. You then alter the default privileges, so any new privileges created will have usage. OLTP will have usage, and any new table that's created will have the DML commands associated with it. So it can select, insert, delete, and truncate. You might also want to give it its own statement timeout, because if it's doing a web request that's in a web cycle, there's only so long you want it to run, unless things start backing up. Give it a higher but not huge amount of work mem, and set an idle and transaction session timeout, because the computer's running this, not a human, so it shouldn't dawdle for more than a second, or you get idle and transaction problems. So. Let's say you have a big old database and you have analysts who use PSQL or some graphical client to log into it, and they want to do big old queries, but you don't want them to be able to change things and mess around with it. So you can say, okay, it has usage on public, so it can read things in public. It has its own schema workspace, and it can create new things in this workspace schema. So if it wants to, the analyst wants to create tables that are summary tables or something like that, it can do. But the only thing it can do to the ones in public is select from them. You revoke any statement timeout because these queries could be huge. You give them lots of work mem, hope that 500 of these analysts don't log in at the same time, and you give the analysts a more generous idle and transaction statement timeout. Let's say a whole minute. This is a very common thing that is asked for, which is create a user that's read-only. So you create the user, grant usage on the schema so it can see the tables, grant select so it can read from them, and then alter the privileges to excuse me to alter the privileges to that new schemas and new tables will get that privilege as well. But we haven't granted any ability to modify these. And by default, a new role doesn't have any ability to modify anything. It doesn't have any privileges at all, except what it gets from public. So now the user can read only. But you might say, well, but I have like all of these schemas already and all of these tables, and I really don't want to go through all of this stuff. So the other thing you could do is just alter the table so every transaction it starts is by default read only. Now, this is again safety, not security. A read-only user can happily set the default transaction mode read-only to false, and then be able to modify it. But this is like a cheap and cheerful way of doing the same thing. This is an example of creating a user that can only do DML. It can't create new tables anywhere or things like that. So it's patterned very vaguely like the analyst query we saw earlier, or the OLTP query. Probably the most surprising thing about the public pseudo role is that the pseudo public role grants execute on all functions. Generally, that's what you want. But sometimes you want to lock down the database so that only particular roles can execute particular functions. If that's what you want, you can do this. You can revoke all the execute on all the functions in schema or wherever else there are functions from public, and alter default privileges to revoke execute on newly created functions. And after that, if you want a new role to be able to execute a user-defined function, you have to explicitly grant execute on that particular function. Let's say you want to give you have a junior DBA. You want to give them access, fairly high level of access to the database, but you don't want to actually give them a super user. So you can give them access to all the schemas and all the publics, and you can give them DB monitor. So they could do a lot of things, but they don't have the full facility that a super user would have. For example, they can't create new roles and things like that. So that's one way of, if you only trust your DBA so far. And this is a way of creating sort of a faux super user. This is a user that's not a super user, doesn't have the super user attribute, but could do pretty much all the things you normally expect a super user to do. So it has a lot of power, but not all power. And this is kind of a simplified version of what happens when, for example, RDS creates the RDS admin role. Which is not a super user, but is kind of your substitute for super user. So this is another possibility. If you have a real super user, you probably don't need to do this. You just use the super user for this kind of stuff. Now, there's one interesting thing about this. You notice this role can't log in. So you can't actually log into the database as PGadmin or PGX admin, because the idea is users with a personal role will log in as that role and then SU to the SU, and then use set role, kind of like sudo, to adopt that that PGX admin role to just do PGX admin things. So that by default, the personal role doesn't have all of those privileges. It just has whatever privileges a typical user has. Okay, and just some tips. Don't use the super user for anything besides granting privileges. That's really all it should be. It should be the source of all privilege, but you don't use it to manage the database unless you really have to. So remember also that a newly created role only has what public has, which isn't much. For example, it doesn't have access to any tables, so you'll have to grant those if you or grant it. Create a role that has access to all tables, and then grant a newly created role membership in that role. Don't revoke connect from public because you'll be surprised. Just use login instead, and only revoke temporary or execute from public if you've built a role hierarchy that allows those things that allows the right roles to use those. Don't just go in and say, oh, look, public has some things and revoke them without thinking through who you want to have to do what. Yeah, and so above all, when you're designing a role, when you're going into play with the role system in a real life production database, keep it simple. Don't over-engineer your role system, because the role system is very powerful and fairly complicated, and you can end up with kind of a bad situation because you've just built too much role machinery. You usually don't have to. And there is my presentation. Are there any questions? Complete silence.
Well, that was a lot of information.
But it was good. I liked it.
I'm sorry?
Oh, it looks like it's...
I said it was good. I like it.
I'm very bad.
David says, this is great, thanks. Real quick, can you say more about large objects? I know it's not the main topic.
I should have never mentioned them. I have raised the specter of large objects. Way back before Postgres had Toast. It's fine. It's interesting. So the Toast system, for anyone who doesn't know, is the system Postgres uses for big things, like that can't fit in a single row in the main table structure. Postgres didn't always have Toast, but there was a desire to store big stuff. So there's kind of a separate subsystem in Postgres that allows you to create large objects. A large object is basically a big binary blob on disk, same kind of size limits as a toasted column, and they're referenced by their object IDs. So you can think of it as a single special table that can only store that only has one column, that can only store blobs, and its primary key is an object ID. There is one advantage large objects have over toasted values, which is you can use them in kind of a stream way, like doing seeks into them rather than grabbing the whole thing and pieces of it. However, they have a lot of database management issues. They complicate your database can complicate your database significantly. So unless you really, really, really need some very specific characteristics of large objects, I would say stay away from them and just use ByteA.
And David says thanks. Anything else? Any other questions? Well, that was a great talk, Christophe. Thank you so much for doing that for us. Also, thank you to PGUS and PGX. SFPUG will be back on Tuesday, August 13th with Open Telemetry Databases and Machine Learning, Troubleshoot Like a Pro with Adam Furmanek. We are looking for a speaker for September. So if anyone here is interested, please feel free to PM us. Our next event after that will be Tuesday, October 8th, leveraging a PL Rust extension to protect sensitive data in PostgreSQL with Sushant Rao and Rajan Palanaval. The upcoming conferences are PGConf NYC on September 30th through October 2nd in NYC. and PGEU October 22nd through 25th in Athens. We will send a link by email when the video is ready, and you can watch our social media. We are at Bay Area Postgres on Twitter, Mastodon, and Blue Sky, and Bay Area PostgreSQL user group on LinkedIn. And another reminder that we do in fact need speakers. So if anyone is interested in speaking, you want to try out that new talk that you want to put into a big conference but aren't so sure, we are the perfect place to try that out. Thank you so much, everyone, for being here. Hope everyone has a great rest of the day, and we will see you next month. Thanks so much. Bye-bye.